All right, so this week we're going to take a look at section 2.2. Okay, as I said, we'll spend whole week on this one section. Okay, section 2.2 is about what we call unit circle trig. Okay, so this will be the first time we've actually seen the trig functions in this class. Okay, you might have done them before, like sine, cosine, tangent. If you've done that before, that's what we're going to start to look at today. There's a little bit of calculator involved, but not today, I don't think. All right, so I need you to just start off by sketching this diagram. Okay. So the diagram has your two x and y axes. Okay, it's got a circle of radius 1, and I've labeled the degrees going around. Okay, you always put 0 on the positive x-axis, and then go counterclockwise. So 90 is at the top, 180 is on the left, 270 is at the bottom.
Is it the 1? Is that the radius? 1?
That's the radius of the circle. Okay, and making it a radius of 1 is what makes this a unit circle. Okay, any questions on the diagram so far? All right. Okay, so every angle that I draw on this circle can be represented as a coordinate. Okay, so let's say, for example, I put a point right there. Okay, and I'm going to make an angle out of it. Okay, that's one side. That's the other side. That angle right here corresponds to some coordinate. Okay, this coordinate has an x value and it has a y value. Okay, I went over a certain amount and I went up a certain amount to get to that point. Okay, and the whole goal of unit circle trig is to figure out that coordinate. Okay, that's all we really have to do. Now, the disadvantage of unit circle trig is we can only use it with certain angles. Okay, you can't just put any angle you want. You can only do angles that are multiples of 30 or 45. Okay, those are the only angles that we can work with on the unit circle. All right. So in a minute, we're going to start off by trying to figure out not the coordinate of this angle, but we're going to try to figure out the coordinates of 0, 90, 180, and 270. Since those angles are on an axis, they just go straight in a direction. Okay, so those angles are easier to figure out the coordinates. Okay, there's two directions we can go on the circle. Okay, if we move counterclockwise, okay, like the way I've drawn that angle, that's a positive angle. If we go clockwise, that's a negative angle. Okay, I think I showed you guys that last week. Okay, so counterclockwise is a positive angle, clockwise is negative. All right, so generally when we have a negative angle, we don't like to work with angles that are negative because then we have to think about going in this other direction. So what we're going to do is take angles that are negative and turn them into positive. Right. So let's take a look at this angle. Okay, negative 90. Okay. Does anybody know what that would be the same as if I went the other way? 170. Yeah, it's the same as 270. Can anybody tell me what do you add to negative 90 to get to 270? And here's a hint. If you start here, you're adding 1 revolution, or 360. Yeah. So if you have an angle that's negative, and you don't want to work with it being negative, you can just add 360 to it, and that'll make it positive. Okay. Now what if you had this? Well, how many times would you have to add 360 here? Twice. Okay, you'd add it twice. we don't care how many times we've gone around. All we care is what is this coordinate right here. Okay? How many units down did we go? Right? Whether it's this, that has exactly the same coordinate, and so does that. Okay? So our goal is to try to take an angle that's negative and make it positive if we need to. What do you think I'd do if I had that? 630. Okay, it's kind of the opposite. I got an angle that's too big. I can subtract 360. Okay, so if you have, if you get a number that's really big, like 1,350 degrees, okay, you're not sure how to graph it. Keep subtracting 360 as many times as you need to make that angle smaller. How small do you want to make it? Somewhere between 0 and 360. So I would stop here. Don't subtract 360 again, because if I do that, what's going to happen? Then it's going to go negative. All right? All we care about is this coordinate right there. Okay, so, oops. So to reduce an angle that's bigger than 360, subtract 360 as many times as you need to until you finally get an angle between 0 and 360. Okay, and likewise, if you have a negative angle and you need to make it positive, you can add 360 as many times as you need to until your angle is between 0 and 360. Don't add 360 too many times, otherwise it starts to get too big. Right, so if somebody asked me to sketch like a 2,000 degree angle, okay, off the top of my head I might not be sure what that looks like. So I'd just subtract 360. Well, I went one too many times until I get 200. And now I can visualize where 200 would be. A lot easier than 2,000. I know 200 would be a little bit past 180. Okay, just a little past 180. Okay, any questions on that? All right, so next we're going to look at our definitions of the 6 trig functions. Okay, and they're all going to be based on knowing the coordinate that corresponds to an angle. Okay, so I'll go back and I'll look at that circle that we first drew and see if we can figure out some of the coordinates for maybe the 0, 90, 180, and 270. Okay, but you have to know the coordinate. If you can't figure out the coordinate, then you can't do anything with unit circle trig. You're stuck. All right, so let's go back and take a look at our diagram. And let's look at 0. Keep in mind that this is a unit circle. Right? So for 0, we've gone 1 unit to the right. We haven't gone up and down at all. Okay, so what do you think the coordinate would be for 0 degrees? If you've gone 1 unit to the right. Yeah, this is the coordinate 1, 0. Okay, going 1 unit right. Okay, how about the coordinate for 90? It's 0, 1. Okay, we know the distance from the center to the edge of the circle is 1, because we labeled that earlier. And 90, you've just gone straight up right to the edge of the circle. So that's 1 unit up. Okay, we have not gone left and right. Okay, how about the coordinate for 180? Yep, that's negative 1, 0. Again, you've gone from the center all the way to the left edge. We know that's a distance of 1. Since it's left, we make it negative. And how about my coordinate for 270? 0, -1. Those are always the coordinates for 0, 90, 180, and 270. Okay, that never changes. Okay. Questions on how we got those coordinates? Okay, now, each coordinate has an x value and a y value. Once you have those two values, you can find any of the trig functions that you want. Okay, so our first three trig functions are sine, cosine, and tangent. We'll usually see them abbreviated sin, cos, tan. So, if you want the sine of an angle, step one is to figure out what's the coordinates of that angle. Once you have the coordinate, okay, whatever one it is, sine is just the y value. So for actually sine, you don't need the x value. All you need is the y value. Okay, if I ask you for the cosine of an angle, step one, find the coordinate of the angle, and then whatever the coordinate is, write down the x value. Okay, so for cosine, you don't need the y, just the x. And then lastly, tangent. Okay, if I ask you for the tangent of an angle, step one, find the coordinate. Step two, take y divided by x. Okay, so any questions on those three definitions? So we find a coordinate, and then we plug in. Okay, our next three trig functions. These ones might not be as familiar with. It's cosecant, abbreviated CSC, secant, abbreviated SEC, and cotangent, abbreviated COT. Okay, when we do an abbreviation, we usually use the first three letters. With cosecant, we can't do that. Okay, the first three letters are COS, and we already used it. That's why they use the letter for each syllable, cosecant. Okay, and I wrote them across from each other because all you have to do, if you have the one on the left, you flip it, and that gives you the one on the right. How could you think of y as a fraction? What number could you put in the bottom?
1.
You could put 1. Okay, just watch this part though. Okay, just leave it as y. And now if you flip y over 1, what would you get? 1 over y. Okay, that's the cosecant. It's just the sign flipped. Okay, and if we follow that same relationship, what do you think the secant is? It's 1 over x. Secant is the cosine flipped. And what do you think cotangent is? X over y. Okay, it's the tangent flipped. So a lot of times what I do is I find the three on the left first, and then I flip each one of them to get the three on the right. That's it. Okay. Those angles that we were working with, the 0, 90, 180, 270, okay, they have a special name, and they're called the quadrantal angles. Because all of those angles land right on an axis. And the axes are what separate into quadrants. So, any questions on what the quadrantal angles are or any of these 6 definitions? Right, if you've done SOHCAHTOA, like that kind of thing, opposite over hypotenuse, this is the same thing. Okay, when we do right triangle trig in here, like you did in geometry last year, I'll explain how this is exactly the same thing. There's no difference. Okay, but I'll save that for then. Right, so I'm just going to summarize the two steps again, how you do unit circle trig. Step 1, find the coordinate. Okay, find the coordinate that represents the angle. Sometimes they'll give you the coordinate. Okay, so if I give you a coordinate, you don't have to do step 1. It's already done for you. Okay, after you have the coordinate, step 2 is to use the coordinate from step 1 and the definitions we just went over and find whatever they're asking for. Okay, so if they were asking for the sine, I'd get the coordinate and then I'd use the y value. If they were asking for cosine, I'd locate the coordinate, then I'd use the definition for cosine, which is the x value. Okay, what we'll do is practice finding all 6. Okay, we'll try each one of them. So the first example says you have the point -1/2 comma square root 3 over 2. Okay, that's a point that represents some angle on the circle. In this problem, we are never going to know what the angle is. Okay, we don't need to. All we're going to do is describe 6 things about the angle. Okay, the 6 things that we're going to describe are the sine, the cosine, the tangent, secant, the cosecant, and the cotangent. And you might say, well, how can you describe all those things without ever even knowing what the angle is? Same way you could describe what somebody looks like without knowing their name. Okay, I can look at anybody and describe what color shirt they're wearing, their eye color, hair color, but I don't need to know their name to do any of that. Okay, same idea. Okay, we'll describe a bunch of things about the angle, but we're never going to know the name or the size of the angle. All right, so step 1, find the coordinate. That's already done for you. Let's just make sure we know which one's x and which one's y. Emily, which value here is my x? The first one, yeah. And y is my second. Okay, so x is -1/2. Y is square root 3 over 2. And now we'll go through and find all 6 trig functions. Okay, let's start with sine. Natalie, what's my definition for sine? Sine equals what letter?
Y over 1.
Yep. Sine is y. And what was my y in this case?
Square root of 3 over 2.
Square root of 3 over 2. That's it. That's the sine. If that's all I asked for, you'd be done. Okay, sine and cosine are the fastest two to really do. Okay, how about John? What's my definition for cosine? X. And what's x in this case? -1 over 2. That's it. That's cosine. Okay, now we'll look at tangent. Amy, what's my definition for tangent? Okay, it's y over x. So the way I've written my table, it's almost like just imagine putting a division sign right there. That's y. That's x. Okay, so it's root 3 over 2 divided by -1/2. Now, when you're dividing fractions with the same denominator, denominators cancel. Okay, some people do that by flipping and multiplying by the reciprocal. Take what's in the bottom, flip it, and multiply by what's in the top. Okay, if you do it that way, they still cancel. So that's gone. And I'm left with square root 3 divided by -1, which is negative square root 3. Hey, any questions on the sine, cosine, or tangent? Okay, now to find the 3 on the right, all we have to do is take what we already have and do something to it. Does anybody remember what we got to do to each one of these? flip them. Okay, flip each one of them, and that's going to give you the one on the right. Right, so Jason, what would be my cosecant? 2 over the square root of 3. And does anybody remember how we fix that so we don't leave the square root in the bottom? What do we have to multiply? Yep.
You multiply the top and bottom by square root of 3.
Yeah, I think we talked about that when we did the distance formula. Okay, reducing square roots and not leaving the square root in the bottom. So you have 2 times the square root of 3 in the top. And Kelsey, what do you get in the bottom? 3. Square root 3 times square root 3, that's square root 9. Or 3. So anytime you end up with a root in the bottom, you do need to fix it. Okay. Carter, how about my secant? What will that be?
Would it just be 2 over negative 1?
Yeah, 2 over negative 1, and if you divided that out, it's just negative 2.
Yeah.
Yeah. And lastly, my cotangent. Well, if we look at tangent, I don't have a fraction here. Okay, so Courtney, how could I make this into a fraction so I could flip it?
Put it over 1.
Yeah, if you want, just put it over 1. And now we've got something to flip. Where you put the negative doesn't matter. Okay, it was right next to the root 3. When I write a fraction, I usually just put the negative in the top. If you want to put it in the bottom, that's fine. Okay. Anybody think they can tell me what that would come out to once you clean it up?
Wait, how did you get that for that?
This one?
The cotangent was x over y.
Yeah, so tangent is y over x, and this is x over y, so if you have tangent,
You just take them.
I'm just flipping it, yeah. You can go through the whole x over y, but then the 2's are just going to cancel and all that stuff. Yeah. Okay, so just take your tangent and flip it. That's the shortcut. Okay, and what would I get once I fix that? Yeah, negative square root of 3 over 3. You would multiply top and bottom by square root of 3, just like we did this cosecant. Okay, if this was on the test, this would be 6 problems. Okay, each one of these would be its own question. Okay, so you'll probably have about 10 of these to do on a test. Probably not going to ask you to do 6 all with the same coordinate though. Okay, I'll give you a coordinate and I'll say, find the sign of this coordinate, and only the sign. Okay, so you just write that and you'd be done. Okay? But we'll practice all 6 for today. Okay, any questions on the 6? Okay, and keep in mind, we never knew the size of this angle, and we won't. We could, we have enough information to figure it out, but that's later on next academic week. All right, so we're just describing 6 things about the angle. All right, so here's another one, very similar. It says, find all 6 trig functions of the point square root 2, comma, square root 2 over 2, comma, square root 2 over 2. Now, I said we're not going to know the angle, but does anyone have a guess what angle that would be? If you drew your circle and you went right and up exactly the same amount. It is. This is the coordinate for a 45-degree angle. Tomorrow, I'll show you how you get that coordinate. For today, I would give it to you. Okay, but it is a 45-degree angle, but you don't need to know that for this problem. Okay, so we'll just go through and find all 6 trig functions. Bailey, what letter is sine equal to again? That's
X, or no, Y.
y. What's my y value here?
Your Y value is 2 squared over 2. Or square root of 2.
Yeah, square root of 2 over 2. And which one, since they're the same, was y the first or the second? The second. In this case, if you mixed them up, you'd be okay because they are the same, but we should know which one x and y is. Okay, so that's my sign. Sydney, how about my cosine?
X,
X, and what's x in this case? Square root of 2 over 2. Right, and lastly, my tangent. I'm taking y and I'm dividing by x, but they're the same. So what do you get when you divide two things that are the same? 1. Okay, so the tangent is 1. Okay, any questions on sine, cosine, or tangent? Okay, Malin, what do I do with my sine to get my cosecant? Yeah, we just flip it. 2 over square root of 2. And Macy, can I leave this as my final answer? Yes. Anybody think there's anything we have to fix with that? Yep. Right. Just like the last one, we can't leave a square root on the bottom. So what would you multiply by here, Melissa, to fix that? Yep. Square root of 2 over square root of 2. And you get 2 square root of 2 in the top. Square root of 2 times square root of 2 is 2. And now I have a 2 on the top and a 2 on the bottom. So what happens to them? They cancel out. So the answer is just square root of 2. Now we should be able to do the secant very quick. Okay. What do you think the secant would be? Square root of 2. Since the sine and the cosine are the same, the secant and cosecant are the same as well. Okay. And Ashley, how about my cotangent?
it would be,
Think about it. We have the tangent, right?
mhm.
So just take that number and flip it.
What if it be 1 over 1?
It would still be 1 over 1, which is, what's 1 over 1? 1. Okay, so if you have 1 and you flip it, it stays the same. That works for one other number as well. Does anybody know what other number you flip and it stays the same? Negative 1. If you have 1 over negative 1 and flip it,
Oh.
it's still the same. Okay, but those are the only two numbers that stay the same when you flip. Okay, again, that would be 6 separate questions on the test. Okay, any questions on this one? Okay. Does anybody feel like they need to do another one where they're given the point? Anybody? No, we're okay? All right. This one has a root in it, so we would end up with some roots in the bottom when we flip things, and we'd have to fix that. Okay. But if we're okay, I'll skip going over another one with coordinates. Okay. All right, so let's try this one. Find the 6 trig functions of 90. What's different about this one? It's giving me an angle. The angle does not help me directly to do unit circle trig. What do I really need to have? Not the angle, but
The coordinate.
I've got to have the coordinate. If I can't figure out the coordinate for 90, then I can't do this problem using unit circle trig. So if I forget what the coordinate is, I make a sketch. I say, okay, 0's here, 90's here. So I went straight up to get to 90. And what's the coordinate for that? 0, 1. The nice thing about working with the quadrantal angles is there's never any square roots. The only arithmetic you're going to have to do is with ones, negative 1s and 0's. Okay, so now we'll just go through all 6 using that coordinate. Okay, Becca, what's my sine?
1.
Yeah, my sine is 1. It's the y value. Okay, Alyssa, what's my cosine? 0. That's my x value. Okay, and Steve, what's my definition for tangent?
It's y over x, right?
Yeah, it's y over x. So basically, you just look at what you have right here and just divide it. 1 divided by 0. And now we just need to write what that is. What happens when you divide by 0? Not 0. No, not 1.
Is that like an error?
That's undefined. Okay, you can't divide by 0. Can't divide by 0. So just write undefined. Okay, and that means all kinds of things, like if we were to try to draw a picture of tangent, something very funny would happen at 90. The graph wouldn't be there. Okay, we're not going to look at the graph today, but later on we will. Okay, Wesley, how about my cosecant?
That should still be 1.
Yep, it'd still be 1, because if you flip it, 1 flips, stays 1. How about if you flip 0?
Undefined.
That would be undefined. Think of 0 as the fraction 0 over 1. Very different than 1 over 0. 0 over 1, if you flip it, becomes 1 over 0. Undefined. And what do you think would happen if you flip something that's undefined? What's 0 divided by 1? 0. 0 divided by 1 you can do, and that is 0. Okay. Any questions on finding 6 trig functions of 90? Okay. Right, this one, it's just asking for the first 3, just the sine, the cosine, and the tangent. Okay, and the angle that we're working with is 3 pi. What is that? It's an angle. But what's it's a radian. Does anybody remember how we change radians? We probably want to change it to degrees. You don't have to, but it is easier to think about in your head, I think. Yeah, 180 over pi. So the pi's cancel. And 3 pi is the same as 540 degrees. Now, even though it's degrees, I still don't like this angle. Okay, what do you think I don't like about 540? It's over 360. I want to make it smaller. Okay, so how can I make it smaller? Yep, subtract 360. So that's exactly the same as 180. And that, I know where that is on the circle. Where's 180? Yeah, Mason.
-1, 0.
Yeah, you've gone left. It's right there. So you've gone left 1 unit, as you just said, -1, 0. Now we're good. Hey, so Kelsey, what's my sign here? Yep, my sine is 0. Okay, Stephen, my cosine?
I don't know, I missed most of this, so I just kind of gave up.
Can anybody tell him what's the definition for cosine? What letter?
X.
X. So Stephen, what's my x value in this coordinate?
-1.
-1. Yeah. So we'll make sure you get those definitions. Okay, and then my tangent? The tangent is 0. It's y divided by x. 0 on the top of a fraction is okay. 0 divided by a number, but you can't do a number divided by 0. No. Okay, remember it that way. Number divided by 0 spells no. You can't do it. No. Okay. Any questions on that one? All right. Why don't you try that one? Okay. So the angle is 11 pi over 2. See if you can find all 6 trig functions for that angle. All right, so my overall goal here is to figure out what is the coordinate for 11 pi over 2. Okay, a couple things we want to do to make this easier to work with. What's the first thing we should do here? Yeah, we should change it from radians to well, this is an angle, but we just want to change the unit from radians to degrees. Okay, let's change to degrees because most people have an easier time visualizing that. Okay, what do we multiply by to change to degrees? 180 over pi. So the pi's cancel. If you want to reduce the 2, you can do that as well. And when we do 11 times 90, we get 990. Okay, any questions up to that stuff? So we've got an angle in degrees, but this angle's too big. So what do we want to do with that? Yeah, if we do it once, it's still too big. Do it again, we get 270. Okay, all the angles tonight, if I ask you to find the coordinate, they have to come out 0, 90, 180, or 270. It's got to be one of those 4. Okay, so now if I do my circle, where's 270? Yeah, it's on the bottom, which is 0, negative 1. Right, so Jason, what's my sine?
1.
Yep, negative 1. Can you do my cosine too? 0. And then when I divide these, what's negative 1 divided by 0? Undefined. Okay, Bailey, what do we get if you flip negative 1?
Negative 1.
Stays the same. How about if we flip 0?
Undefined.
Yeah, undefined. Okay, and Emily, if we flip undefined, you get 0. Okay, any questions on that? All right. So we've got a little bit of time left. Okay, I'll give you the last 15 minutes to work on the homework. Again, we won't have time every day, but some days we have more time than others. Okay, and the homework, it's on 116, 11 to 27, odd, and number 22.